Why do gradients of perpendicular lines give us a product of -1? Let us first begin with a straight line. Let's call it L1. And also create a right angle triangle using horizontal and vertical line segments. Let's call the horizontal line segment B and the vertical line segment A. With that, we can find an expression for the gradient of the line, calling it M1. When we run B units from the left to the right, we find ourselves moving upwards by A units. Hence, M1 can be expressed as A over B. Now, let us duplicate this line, make it red, and rotate it by 90 degrees so that it is perpendicular to the green line. Let's call this line L2. Now you will notice that the measurements of the triangle has not changed. However, the vertical component is now B and the horizontal component is now A. So now let us find an expression for the gradient of L2, calling it M2. Right now, as we move A units from left to right, we find ourselves moving downwards by B units. Or in other words, we are rising by -B units. As such, the expression for M2 is now -B over A. M1 is A over B, M2 is -B over A. Multiplying the two together, we now see how easily the A's and B's cancel out each other, simplifying to a very nice -1. And hence we conclude this very simple proof of why the gradients of perpendicular lines give us a product of -1.